Okay, and welcome to the tutorial for our last SPSS lab. This one dealing with correlation and regression. So on the left, I've already opened up the SPSS lab data file, and in it you see all of the columns of data that we've used in previous labs. And if you remember, the labels button can toggle those nominal data, the labels on and off. So here we have male, female, and whether the individuals ate spinach or not in our forearm experiment, our Popeye study. So I'm just going to leave that toggled on. I've also added 4 other columns to this data set at the end. So the first 2 columns, T39 and T1700, relate to a study where researchers were investigating first impressions. They wanted to see how fast people could judge others. And so what the 2 columns represent is in T39, the researchers showed or flashed a face on the screen for 39 milliseconds. That's 39 one-thousandths of a second. And the participants had to judge how threatening the face was. Then in the second column, the score then represents the rating on or the average rating for a face on a scale of 1 to 5. And then in the T1700 column, the participants saw the same face, but it was flashed for 1700 milliseconds or 1.7 seconds. And once again, the scores represent the average rating for each face. So column 1 was a very, very fast exposure, and they wanted to see how the how accurate or threatening the face was rated, and then they saw it for a little bit longer, and they wanted to see how threatening the face was rated. The second 2 columns, the last 2 columns really, are related to a study on the relationship between GRE scores, or the Graduate Record Examination. That's kind of like the SATs for getting into graduate school in psychology, and grad school GPA. So on the left we have GRE scores, on the right we have grad school GPA. So we're going to use those in this analysis. But to start with, we're going to do a fish tank study. And for this one, I want to give you a little extra practice entering data. So on the right side of the screen here, I've got a data file that's available on Blackboard that has all of these data included already. Actually, I've added a couple of cases since then. And then on the right, we see the fish tank size and fish tank count columns. So we need to enter those into SPSS. Now, do you remember how we first enter data that we've never entered before? Well, hopefully you remember we have to click on Variable View at the bottom here. Variable View is where we define our variables. So I'm going to type in tank size as a variable name. And we can accept all of the defaults here, other than I just want to make sure that I tell SPSS that this is a scale variable. It's the number of gallons that a tank will hold, and that is obviously a ratio scale, so that'll work. And then the last variable I'm going to call fish count. Once again, we can accept all of the defaults here, and this is a scale variable because it is the number of fish in the tank, so that would be also a ratio scale. So now that I've defined the variables, I can click back on Data View, and you see we have these 2 columns here. I can very quickly enter the data, 5, 10, 15, 25, 55, 80, and for fish count, 3, 6, 8, 11, 15, and 20. There. Easy peasy, mac and cheesy. So now that I have the data entered, if you follow along with the instruction sheet for this lab, I first want you to write a non-directional hypothesis for this fish tank study. Basically, the fish tank study is looking at the relationship between the number of gallons a tank will hold and the number of fish that are kept in that tank. So what you're going to do for this lab is open up your word processor. I will open up MS Word here, and I'm going to close that one down and give a new blank document. And all I want you to do is just identify or answer each of these questions. So for number 1, it's write a non-directional research hypothesis. So I'm going to label that H sub 1, and I will type out saying that there is a correlation between tank size in gallons and the number of fish kept in that tank. That's H sub 1, and then I will call H sub 0, or the null hypothesis, that there is no correlation between tank size in gallons and the number of fish kept in the tank. There we go. All right, so now I've done number 1. I've labeled or identified a non-directional, I'm not saying whether this is positive or negative, but a non-directional correlation between tank size and number of fish, and the null hypothesis is that there is none. So next we're going to conduct the analysis, create a scatter plot, blah, 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 blah. So I'm going to hide this for now. Go back to SPSS. Now to conduct a correlation analysis, we once again go to the Analyze menu. That's where all the statistical tests are held. And if you scan down, you will eventually come to one that says Correlate. Correlation analysis, correlate, makes sense. And there are different types of correlation analysis. For this class, we're just doing bivariate, meaning 2 variables. We're going to check for a correlation between 2 variables. So I click on bivariate correlations, and here's a list of all of the variables in our study. I am going to just simply move over tank size and fish count. Now, if I wanted to, I could click on options and tell SPSS to give me the means and standard deviations, like the average tank size and the average number of fish in the tank and so on. I don't really need to, so I'm not going to. It's already set to give me Pearson's correlation, which is the correlation coefficient that we've been learning. There are other types for different types of data. Then we're going to do a 2-tailed test because it's a non-directional hypothesis, and we're telling it to flag significant correlations. In other words, it's going to put a couple of asterisks by any correlation that is significant just to help us identify it. So that's really all you have to do. Just accept the defaults and you're pretty much off to the races. So I click OK. And in just a couple of seconds, we get our output. So here is the output for a correlation analysis. And the first thing you'll notice is that there is some duplication in there. And it's just a weird, I don't know, curiosity about the people at SPSS. But when they had SPSS build these tables, they show the correlation between tank size and tank size, which is why we get a perfect correlation. It's correlated with itself. And then tank size and fish count. And then it also does fish count and tank size, and fish count and fish count. So across the diagonal, this table is just a duplicate of itself. So we really only need to concern ourselves with everything above that diagonal point, the perfect correlations. So here we see Pearson's correlation between tank size and fish count is 0.977. There's no negative symbol, so we know it's a positive correlation. And 0.977, hopefully you immediately see, wow, that's pretty strong. And notice the couple of asterisks here. The asterisks tell us that it's significant. But if we go down to the second row where it says significance, 2-tailed, we see the exact p-value. Here, the probability of getting a correlation between these 2 variables of this size by chance alone is exactly 0.001. So it's 1 in 1,000. And that's based on an N of 6 cases. There are 1, 2, 3, 4, 5, 6 tanks that we looked at. All right, so that is the result of our conducting the correlation analysis. Now, the second point is to create a scatter plot for the data. So let me show you how to create a scatter plot. Once again, well, not once again, this time we're going to go up to where it says graphs. And specifically, the very first menu choice is Chart Builder. So if I select Chart Builder, I get a blank gallery where I can build lots and lots of different kinds of charts or graphs. Well, if I scan down this list of graphs, I come to scatter, and that's what I want. Remember, for correlational data, or when we're trying to look for relationships between scale data, a scatter plot is the best way to go. There are many different types of scatter plots, but I'm going to take just the first one here and drag it up into my little, I guess you can kind of call it a canvas here, where we set up our graph. And SPSS puts in some fake data here, so if you're doing this, you might get very different looking dots than I have. And don't worry about that. It's, again, just a fake model for you. It hasn't done any calculations yet. Next, we have to tell SPSS what the X and the Y axis are. And since we are doing a scatter plot looking at tank size and its relationship to fish count, I'm going to drag tank size. So I just click on that and drag it down until that box gets highlighted, and that becomes the x-axis. And then I'm going to take fish count and drag that to the y-axis. And now I've built my, my graph. So when I click OK, voila, we see a scatter plot of the data. So for each of these dots, we can look at the number of the tank size, and then how many fish were actually in that tank. Now there's one other thing that I want you to do. If we double click on this graph, it's going to activate it. And when it activates it, this allows us to modify lots and lots of components. And it'll make it look really busy. But all I'm going to do this time is just click on this 5th little button right above the graph that says, if I hover over there, you see that little text that came up that said add fit line at total. So when I click on that, what SPSS is doing is calculating the least squares regression line. If you remember that from the regression homework in the past. And it even gives us the regression formula in kind of an odd format. It's y equals a plus bx. That's the way SPSS writes it out. But it's the same, otherwise the same concept that we did before. We just had y equals bx plus a in in our homework. So now that it's plotted the regression line for us, we can just close things up by clicking the box, and that change gets put into our graph. So we now have a scatter plot of the data. All right, so that was step 3. We've conducted a correlation analysis and we conducted a scatter plot. Next is to report the correlation analysis statistical phrase. Now I'm going to show you kind of all of the answers for SPSS, or for this homework in just a second. I want to show you how in APA format we write up the results of a correlation, how we present those statistics. So I'm going to bring up my example write-up. And notice I have the research and the null hypotheses here for item number 1. For item number 2, what I did was I simply, if I notice how there's no box or anything, or no blue lines around the graph in the video here. If I click on it, you see the black lines, so that item is highlighted. I can now just use the copy feature, go up to edit and copy feature of SPSS, and then when I go into MS Word, I can then just paste it in and adjust the size and so on, and that's what I've done here. So that's how I put the scatter plot into the printout. Step 3 was report the results of the correlation analysis, the statistical phrase. And here's the way we write the result of a correlation analysis. We tell the reader that it was Pearson's R, so R. In parentheses, we put the number of degrees of freedom. And if you remember, for a correlation, the degrees of freedom is n, the number of observations, minus 2. there were 6 observations, 6 different fish tanks, and we subtract 2, so that gives us 4. So R with 4 degrees of freedom equals, and then we give the exact correlation coefficient with a comma, and italicized P, we italicize the P for probability, and we say that it was, oops, that shouldn't be less than, that should be equals, because SPSS has given us the exact probability. So P equals 0.001. All right, that's exactly how you would present the results if you were writing this up for a manuscript for publication. The next point in the homework was make a decision about the null hypothesis. That is, did you reject it or fail to reject it? Well, I'm hoping that you realize that because this probability is so small, that is, we had a very strong correlation, that it is not likely to have occurred by chance alone. Therefore, we would reject the null hypothesis. Okay, we're saying that there's not a very good chance that the null is in play here, that it's probably something real. So that was the answer to number 4. And then I ask you to calculate the coefficient of determination. Now, if you remember, the coefficient of determination is simply r squared. So we take r, which is 0.977 times 0.977 equals 0.9545, blah, 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 blah. There was a few other numbers in there. And I just turned that into a percent, 95.45%. So that's the coefficient of determination for this particular analysis. You're going to have to calculate that one by hand. Okay, but make sure you put it in there. You'll be interpreting that in just a moment, but I want to see the work. So I want to know that you know it's r squared. So write it out just like I did. Then for number 6, I say write out the regression formula. So we haven't done, actually letter G, it says conduct regression analysis on the same data. So let's go back to SPSS, and I'm going to just pull up our data file. So here's our raw data, here's our output. So now I want to do a regression analysis. Let me show you how to do that. Once again, for an analysis, we go up to the Analyze menu. We scroll down. We're not going to do a correlation. We're going to do regression. And this one, I'm just going to choose linear regression. So skip that automatic linear modeling thing. We'll just use linear regression. And this window looks a lot like an ANOVA window. And in many respects, regression basically is an analysis of variance. What we're trying to do is see if some variable will predict another, if we have a predictor that will predict some outcome. So in our case, we're trying to see if tank size will predict the number of fish that are kept in that tank. So we're going to drag tank size into the independent variables list, and then we're going to drag fish count into the dependent variables list. Now, you can play with this in more advanced statistical analyses. If we click on the statistics button, we tell it to give us the model fit. That's the default. That's very important. And regression estimates, we can accept that. We're not going to use them in this class, but that's just, again, part of the default. So click continue. Everything else is really status quo. You don't have to do anything else. So just set up your independent variable, your x variable, and your dependent variable, which will be your y variable. And when you click OK, SPSS gives us a bunch of information. So here is, oh, look at that, r squared, 0.955, just like what we already calculated by hand. Don't worry about adjusted r square or any of that. And even don't worry for our purposes about the ANOVA, which is testing the significance of this model. Can the model predict outcomes with greater than chance accuracy? And from the significance level, we see that it does, but I'm not going to have you report any of that. For now, I want to just show you where the coefficients for that regression model come from. And they are in this last table, coefficients table. Specifically, this column here, the unstandardized coefficients, where we have a B for beta. These are the beta weights. The constant is basically the y-intercept. That's A in our y equals bx plus a formula. And then the tank size value, that is the the b, that is the beta weight for x. So we have 0.205, b equals 0.205, and a equals 3.998. So if we go back over to our Word document, you see that I wrote down y prime, because I didn't frankly know how to put a little caret over the y like we did with homework. So another way of writing this is to put y prime, which is just a little apostrophe. Same thing, it means predicted y. Predicted y equals 0.205x plus 3.998. I just extracted those numbers from SPSS and we got our regression formula. And notice the formula that SPSS put in for the regression line is basically the same thing. It just did a little bit of rounding. Let me pull it up a little bit bigger over here. If you notice, we see y equals 4 instead of 3.998. It just rounded that to 4, plus 0.21 times x, and it rounded 0.205 to 0.21. So SPSS did a little rounding for us. I just had you pull out the exact coefficient from the coefficient table in the output. That's the number that I'm going to look for when I'm grading your output. So don't use these rounded values. Use the actual calculated values from the output. Okay? So that takes care of conducting a regression analysis and writing out the regression formula. So the next step in the homework was to determine the estimated number of fish when the tank size was 40 gallons and when it was 65 gallons. So if you remember from the homework, to do that, we simply take our x value and plug it into that regression formula. So I took 2.205 times 40 plus 3.998, and I got 12.198. And then I took I took 65 gallons and plugged that in to this formula. So we did 65 times 0.205 plus 3.998, and that gives us a y value of 17.323. So what it's saying is if we have a 65-gallon tank, we should expect to see about 17 fish in the water, okay, based on the pattern in our raw data. And lastly is an instruction to interpret the results of the study using APA style. So here's the first time we're really getting formal about the way we're writing it up. I basically copied the formula that's in your Module 5 tutorial. Not the formula, but the wording. And you're welcome to do that. Just use my wording and replace the appropriate variables for everything that you're doing today. So this is what I typed up. A Pearson's R correlational analysis was conducted to assess the relationship between the size of a fish tank in gallons and the number of fish kept in that tank. In other words, I first told the reader exactly what type of analysis we were doing and what variables went into that analysis. Next, I tell the reader the results. Results revealed a strong positive correlation between the two variables, and we know that because 0.977 is very strong and it's positive. And then after a comma, I insert that phrase, that correlation phrase that we did back up in number 3. It's very important that you include that in your write-up. And then I tell the reader more specifically what that means. Instead of just saying, hey, it was a positive correlation, I tell the reader more specifically, as tank size increased, the number of fish kept increased as well. And then lastly, I throw in the effect size interpretation. The coefficient of determination revealed that 95.45% of the variance in the number of fish can be attributed to the size of the tank. So that is a quick walkthrough of how you would write up in just a simple paragraph the results of a correlation analysis. All right, and that's everything you need to do for this first problem. Now, as I said, the instructions have you do 3 more analyses on the data set. You're going to look at, for example, the relationships between height and self-esteem. Okay, do tall people feel more or less positive about themselves than people who are not so tall? Then you're going to look at the relationship between post-treatment Beck Depression Inventory Score, if you remember that from back in our ANOVA analysis, and self-esteem. So we're going to see if there's a correlation between a person's depression after they've been treated for depression and their self-esteem. Okay, so that's a second analysis. And then the third, I'm just going to give you a choice. I want you to choose either the face recognition, the first impression study, or the GRE study, and do either of those analyses and write them up. But for each of those three correlations, you're going to do all of these steps. You're going to write out the null on the research hypothesis. You're going to create a scatter plot and paste it into your document. You're going to conduct the correlation and report the phrase here. You're going to make a decision about your hypothesis. You're going to report the coefficient of determination, the regression. You're going to have to do a regression analysis, regression formula, apply the formula, and then interpret the results. Follow this model exactly. A lot of repetition, but repetition is good. And that's all there is to it. Once you've done that, you're going to be uploading for me this document, which will contain all 4 analyses, not just the fish tank analysis, but then the other 3 as well, saved as one file. And then you will also be saving your output file with all 4 of your analyses in it, including your correlation and your scatter plot and your regression analysis for all 4 of those different studies, if you will. So those 2 files, your output file and your write-up, are going to be submitted for credit for this. All right, that's all there is to it. I hope this was clear, and good luck. I look forward to your submissions.